In today's video, we are going to take a closer look at a fascinating aspect of aircraft carrier design: the placement of the island structure. After my previous videos, many of you raised interesting points in the comments about why some carriers had their island on the right side, some on the left, and some had no island at all. In response to your curiosity, today we'll explore how different navies approached this critical design choice, what practical reasons and aerodynamic theories influenced it, and how real-world experience shaped the evolution of carrier layouts. So why is the island, a tall, unmistakable structure on an aircraft carrier, almost always on the starboard side? The Royal Navy pioneered carrier aviation and heavily influenced early island design. HMS Furious began life as a large light cruiser with two colossal 18-inch guns. Then, mid-build, the Royal Navy turned her into a flying experiment. The forward gun was ripped out and replaced by a short takeoff deck, while the bridge and funnel stayed midships and the aft gun remained. It looked ingenious. Aerodynamically, it was a trap. In August 1917, Squadron Commander Edwin Dunning made history by landing a Sopwith pup on Furious, the first landing on a ship underway. To get over the cruiser's foredeck, as it was steaming hard into the wind, he had to execute a risky turn abeam of the superstructure. Then, with the aircraft and ship moving at nearly the same speed, the deck crew hauled him down onto the deck, grabbing the aircraft by special grab handles fitted for this purpose. Days later, on his third attempt, turbulence cowling of the midship's superstructure flipped his pup into the sea and killed him. Trials were halted. The Navy tried a quick fix: remove the aft turret and add a short landing deck behind the obstruction. It didn't work. Airflow between the twin decks was so dirty that only a handful of landings succeeded. Furious had proven the negative: you need an obstructed landing path. By 1918, the Royal Navy took a different approach with HMS Argus, the world's first carrier with a full flush deck. Argus's designers feared any island would create a turbulence over the flight deck, so she was built with a flat top with retractable charthouse and folding masts. Trials soon showed a downside. Without a fixed reference point, pilots had trouble judging height and alignment. Pilots actually wanted a small island as a visual cue. The Royal Navy improvised by adding a temporary wooden canvas island on Argus's starboard side in trials, finding it helped pilots land more accurately. Wind tunnel tests had warned of turbulence, but in practice a modest island was acceptable, especially if the ship steamed with a 5 to 10 degrees on the port bow, so the island's airflow disruption stayed clear of the landing path. Armed with this knowledge, the Royal Navy embraced the island. In 1924, HMS Hermes, the first purpose-built carrier, and a converted HMS Eagle both emerged with starboard side islands, setting a lasting precedent. The choice of the right-hand side was quite deliberate. Early planes, like the Sopwith pup, used rotary engines whose propeller and entire engine mass rotated clockwise as seen from the cockpit. That spinning mass produced strong left-turning tendencies. Engine torque rolled the aircraft left, and gyroscopic precession coupled yaw to pitch, so that left turns naturally climbed, while right turns tended to push the nose down. Pilots, therefore, preferred left-hand turns, especially near the ground. Naval procedures codified a left-hand landing circuit, and to keep the superstructure clear of the approach path, carriers standardized the island on the starboard side. This logic, combined with better visibility for the bridge, meant nearly all subsequent Royal Navy carriers had starboard islands. For example, 1930s carriers like HMS Ark Royal featured a prominent starboard island with an integrated funnel, and even the smaller wartime carriers like Illustrious-class fleet carriers and the light escort carriers like Venerable-class stuck to that configuration. In 1940, the Illustrious-class introduced armored flight decks and hangars, which forced a relatively compact island design to save weight. These carriers had their uptakes trunked into a single funnel uptaking through the starboard island. Designers carefully shaped these island and funnel uptakes to vent smoke clear of the flight path and reduce the air disturbance behind the island that could unsettle landing aircraft. Despite efforts, Royal Navy pilots in World War II did report a barbel effect, a brief loss of lift when passing through the disturbed air right aft of the island. This phenomenon was common on straight-deck carriers and led to many a hard landing. British innovations in 1950s reshaped carrier design globally. Royal Navy Captain Dennis Campbell pioneered the angled flight deck in 1952, first tested by painting angled landing lines on HMS Triumph. When the Royal Navy retrofitted carriers like HMS Victorious and built HMS Hermes in 1959 with angled decks, they kept the island on starboard but often moved it slightly or extended its sponsons to starboard to accommodate the angle. For example, the modernized Victorious got a widened starboard deck edge to fit a new radar and mirror landing sites, altering her island's footprint. The island remained the nerve center, housing air traffic control, navigation bridge and radar mounts. Royal Navy doctrine held that a well-designed island was critical for operation awareness in busy seas like the North Atlantic. In a bold break with tradition, the Royal Navy's latest carriers, HMS Queen Elizabeth and HMS Prince of Wales, featured two separate islands on the starboard side. This unusual layout, unique among world carriers, has roots in practical engineering. The Queen Elizabeth class uses gas turbines and diesel generators in two widely separated engine rooms. By splitting the uptakes into two funnels, spaced far apart, the Royal Navy could place one funnel forward and one aft, each built into its own small island. This twin island design brings multiple benefits. It provides redundancy. If one island's systems are knocked out, the other can assume control. It also increases flight deck area by eliminating a single large base. In fact, wind tunnel tests showed that slim islands cause less turbulence over the flight deck than one big island. The forward island is primarily the navigation bridge, while the aft island handles air operations, essentially a dedicated flight control tower. This split allows each island to be optimized for its role. For example, the aft Flyco island has 360 degrees visibility of flight deck operations. Another motivation was modular construction. Each island could be built and outfitted separately, one in Portsmouth and one in Glasgow, and then installed, which sped up construction. The Royal Navy deliberately kept the islands relatively small to reduce radar signature and interference with the aircraft. The result is a carrier with a distinctive silhouette and a nod to Royal Navy innovation, coming full circle from 0 islands on Argus to 2 islands a century later. The US Navy was initially cautious about islands, influenced by early British practice, but quickly set its own trends. The first US carrier, USS Langley, commissioned in 1922, was a conversion of a collier and featured a flush deck with no true island. Langley's bridge was a little pilot house built into the bow below the deck level, and her smokestacks were swiveling tubes venting off the sides. This minimalist approach mirrored HMS Argus's flush deck concept, maximizing clear deck space at cost of command visibility. As American aviators gained experience, they found Langley's absence of an island made controlling operations difficult. Langley earned the nickname Covered Wagon and was largely a training carrier. USS Ranger, America's first purpose-built carrier commissioned in 1934, was another radical design. Ranger initially had no island and 6 small funnels, 3 on each side of the flight deck, that could hinge outward horizontally during flight operations. The idea was to remove any upright structure that might interfere with air wings when launching or landing planes. Ranger's funnels folded down to keep the flight path completely clear. Like the British, the US was worried about turbulence and obstruction. However, this funnel scheme proved overly complex and only marginally effective. Eventually, the Navy refitted Ranger with a small starboard side island with a mast and a chart house to improve operations. From the late 1930s onward, all US fleet carriers were built with starboard islands. USS Lexington and USS Saratoga, commissioned in 1927 converted battlecruisers, set the pattern. Each had a large starboard island that incorporated the ship's funnels. Their islands were tall and conspicuous. Saratoga's funnel was so large, it was nicknamed the Beehive. The placement was uncontroversial. By then, the standard landing pattern was to come in from the port quarter, making a starboard island the logical choice. Indeed, a 1927 Navy memo noted that the pilots in landing approach tended to favor left turns for better visibility from the cockpit, so having the island on the right was considered safest. A notable awkward island placement was on USS Charger. Originally built for the Royal Navy as HMS Charger, she had a small starboard island placed very far forward. The forward positioning caused such severe wind over deck issues that during trials landings were tricky if the wind came from certain angles. The solution was to always land with a slight starboard wind, so the island blocked less airflow. Crews joked that Charger's Island wanted to be the first to arrive in port, since it stuck out so far forward. After World War II, the US Navy greatly increased carrier size and introduced new technology, but kept islands on the starboard side consistently. The Forrestal-class supercarriers had much larger islands than the World War II Essexes, needed to house bigger radar antennas, new jet-era control rooms and taller funnels for high-power steam boilers. The Forrestal design actually moved the island further aft compared to early carriers, roughly at the midpoint of the ship. This was done to clear more deck space forward for simultaneous launching and recovering of jets. It also balanced the flight deck weight better. Forrestal's island became a template for all subsequent US carriers. Notably, on an angled deck carrier, the landing area is canted about 9 degrees to port, so an approaching aircraft that misses the wires will fly off the port bow, well clear of the island. This dramatically reduced the incidences of planes veering into the island, a huge safety improvement. Later classes like Kitty Hawk and Nimitz refined the island shape for aerodynamics and electronics. The distinctive tiered cake profile of a Nimitz-class island is a result of balancing radar line of sight, funnel clearance, and reducing the barbel behind the island. The United States also began designing islands with some stealth features in mind. For example, the latest Gerald Ford class has an island set slightly further aft and made 30% smaller than the Nimitz-class island. This was to improve flight deck efficiency and to reduce radar cross-section. Ford's island still sits on the starboard side, but because it's farther aft, it visually differentiates the class. Inside, it boasts modernized systems. The navigation bridge and flag bridge have better visibility, and the funnel, since these are nuclear-powered carriers, is just a small exhaust for auxiliary boilers and generators. Japanese carrier design started under influence from the British, but soon took a unique path, especially regarding islands and funnels. The Imperial Japanese Navy's first carrier, Hosho, was the world's first purpose-built carrier to be completed, and she initially sported a small island on the starboard side. Japan had Royal Navy advisors during her design and planned Hosho with forward flight deck, an island amidships, and an aft hangar deck somewhat like HMS Furious. However, in 1923, the starboard-mounted bridge structure was removed, and she became a flush deck carrier. The bridge was discarded because pilots found it interfered with their vision, and it was too small for the officers to effectively command flight operations. Side gallery platforms were added for directing operations. This new arrangement was well liked by both pilots and deck officers. A radio mast was mounted on the gallery on the starboard side after the bridge structure was removed. Later, this was replaced with a larger one, then removed altogether. The Japanese prioritized an obstructed deck and believed they could manage without a traditional island by using wing-mounted control platforms and periscopes for navigation. Early Imperial Japanese Navy carriers thus had novel solutions to avoid islands and funnel smoke. The experimental carriers Akagi and Kaga, converted from capital ships under the 1922 Washington Treaty, were built with multiple flight decks and no islands initially. Akagi in original form had 3 short flight decks, stepping down from bow to midships, and a hangar flight deck aft. She had her exhaust routed through 2 massive horizontal funnels on the starboard side, venting downward to keep smoke clear of landing aircraft. The bridge and control positions were set into the side of the hull below the top flight deck. Kaga was similar, with exhaust vents low on the sides. In these early years, Imperial Japanese Navy doctrine was still undecided. Some within the Navy favored the British-style island for better command and gunnery control, while others felt a big island was a liability, presenting a target and interfering with airflow. By the mid-1930s, operational experience led Japan to revisit the island issue. Akagi and Kaga were rebuilt, each with a single full-length flight deck, and finally given islands. Notably, the Imperial Japanese Navy made a surprising choice. Akagi's new island was on the port side, while Kaga's was on the starboard. This made Akagi and Kaga a complementary pair with mirrored configuration. The Japanese had realized that running multiple carriers all recovering planes from port-side approaches could congest air traffic. Their idea was to operate carriers in tactical pairs, one with an island to port and one to starboard, thus splitting the landing patterns. One carrier's aircraft would circle left, the other right. In theory, this counter-rotating pattern would reduce the chance of collisions and funnel more planes down safely in a shorter time. Additionally, some engineers noted that putting Akagi's island to port helped counterbalance the weight of her starboard side funnel, ducts and machinery. In practice, the benefits of port-side islands were limited. Coordinating opposite landing patterns was complex and pilots sometimes became confused. There were a few near-miss incidents in low visibility, where aircraft lined up on the wrong carrier. By the time of the Pacific War, only 2 Japanese carriers had port-side islands, Akagi and later Hiryu. Hiryu, commissioned in 1939, was initially designed as a sister to Soryu, but modified after lessons from early operations. Soryu had a starboard island, so Hiryu was built with her island on the port side. Hiryu and Soryu formed Carrier Division 2 and were intended to operate together much like Akagi and Kanga in Division 1. Hiryu's port island again allowed a potential opposite landing circuit. However, wartime experience didn't show significant advantages. In fact, Japanese carriers typically still landed all aircraft in a left-hand pattern, even if operating together. The mixed island arrangement mostly served as a visual identifier. Pilots could tell Hiryu from Soryu at a glance. Hiryu was the one with the island on the wrong side, as some joked. For all other Imperial Japanese Navy carriers, starboard island eventually won out. The large Shokkaku-class fleet carriers reverted to the orthodox starboard island. These islands were not particularly large, as the Japanese carriers had lower profiles than US counterparts. Japan also built light carriers and converted carriers that often had minimal or no islands. The small carrier Ryujo had a flush deck and no island at all. She was built very top-heavy and actually had 2 hangar levels in a small hull, so adding an island would have made her stability problems worse. Ryujo instead used a retractable hurricane bridge on the starboard side for navigation. Other conversions like Taiyo, Unyo and Chuyo, ex-passenger liners turned into escort carriers, were given a simple flush deck, with the former hulls repurposed as hangars. In the rush to complete them quickly, they were built without islands. Instead, the staff commanded the ship from a bridge located under the flight deck, sandwiched between it and the weather deck below. At first, there was some debate, but by World War II, the Imperial Japanese Navy had fully embraced the importance of islands for effective carrier operations. Even the massive Shinano, built on a converted battleship hull, was given a starboard side island. Her design showed clearly that Japan had moved beyond the old flush deck concepts. That's it for today. If you like this type of presentation and would like to see more, please leave a like or comment and don't forget to subscribe. Thanks for watching and see you next time.